We have learned translation. Now let us learn scaling. And we know that scaling enlarges or shrinks an object. So let's say, for instance, I have a point of 0, 1, and I want to scale this by 2 units. All right, scale by 2 on the x and scale by 2 also on y. So the scaling factor is represented by s. So my sx and sy is equals to 2 and is equals to 2. So I can just go ahead and multiply x term by 2 and go ahead also by multiplying y term by 2. So the deal now is to have 2, 0, 0, and 2. So I can say this is my scaling matrix, such that if I multiply this is a 1 by 2 matrix, and this also is a 2 by 2 matrix. It's possible, and the resultant will be a what? A 1 by 2 matrix. Now, if the resulting matrix is a 1 by 2, definitely you can just perform the operation. So we have this row multiplying by the column. So we would have if the row is multiplying the column, we will have 0 and 2 plus 1 multiplied by 0, and then the next column will be 0 multiplied by 0 and 1 plus 1 multiplied by 2. Now this will result into 0 and 2. Now what do we observe? We observe that this was multiplied by 2, and likewise this was multiplied by 2, and we had the result to be 2 and we had the result to be 0. Now we can now conclude that the scaling matrix is going to be, for 2-dimensional, will be sx 0, 0, and sy. That's for scaling on 2-dimensional. And on 3-dimensional, it will be sx 0, 0, like a identity matrix, 0, sy 0, 0, 0, and sz. So this will be 3 dimension. So the line is being scaled by a factor. Now the scaling factor on x might be different from the scaling factor on y. Likewise, it might also be different from the scaling factor z. That is why they're different. So let's take another example. So let's say I have 1 and 2, and I want to scale this using 3. Okay, 3 as the scaling factor on the x, and let's say -1 as the scaling factor on the y. Now the one good thing to note is that when the scaling factor is greater than 0, okay, it is being enlarged or increased. The object is being enlarged. But when it is less than 0, it is being reduced. So when we have a scaling factor of 3, is enlarged by 3, and when it is reduced, multiplied by -1, that's less than 0, it is being reduced. So now let's look at this now. So when we multiply this out, we will have a 1 by 2 matrix as a point rather. So that will be 1, 3 plus 2 multiplied by 0, and then we will have 1 multiplied by 0 plus 2 multiplied by -1. So we would have here 3 plus 0, that's 3, and 1 plus -2, and that will give us -2. So we can see from here that this was multiplied by 3 to give us 3, that's enlarged, the x is enlarged, and this was multiplied by -1 to give us -2, which was being reduced. Now, just as we have done for a line in 2-dimensional, we can go ahead and do this, replicate it for 3 dimension. I'm sure you get it. So let's now consider a line. A line makes up of 2 points. So if I have a line 1, 2, 3, and 4, and I want to enlarge it by enlarge or scale 2 units by 2 on the x and by 3 on the y. Therefore, I'm saying that my scaling matrix is 2, 0, okay, 0, 3. Now, if we perform the matrix operation here, the good thing is that both are 2 by 2, and when the result comes out after it has been multiplied, we will get what? A 2 by 2 matrix. So with that being said, now let's evaluate the resulting 2 by 2 matrix. So the resulting 2 by 2 will be first row multiplied by the first column. That's 1 by 2. 1 multiplied by 2, okay, plus 2 multiplied by 0. Now let's move for the first column, first row, second column. So that would mean we have 1 multiplied by 0 plus 2 multiplied by 3. And thereafter we have the same thing, 3 multiplied by 2 plus 4 multiplied by 0. And for the second row, second column, 3 multiplied by 0 plus 4 multiplied by 3. So we would have, this will give us 2, this will give us 6, this will give us 6, and this will give us 12. Now we can observe something. We can see that the whole of x was multiplied by what? 2. And when we have that, it will result into 2, 6. Okay, when we multiply 1 by 2, we get 2. When we multiply 3 by 2, we get what? 6. Now the whole of y was multiplied by what? 3, and then we'll have 6, 12. When we multiply 2 by 3, we get 6, and when we multiply 4 by 3, we get 12. Now we can see how amazing matrix is important in scaling of a vector. Now if we see that it is 1, 2, 3, 4 is the original matrix, and then the scaled matrix, let's say S prime, is scaled by 2 units on the x and 3 units on the y, is this. Let's see if we can draw a graph for this now. So we have this. The line 1 consists of 2 points, 1, 2, and let's say 3, 4 here. Now it is being scaled to 2, 6. This is a line. It is being scaled to 2, 6, and likewise 6, 12. Okay, it's going to be quite, yeah, let's say this is 6, 12, 2, 6. Then when we join the line, we can see that this is larger than this, scaled by 2 on the x, rather is scaled by 2, and on the y is scaled by 3. On the x, just scaled by 2.